Good evening, kids. In today's class, we are going to discuss problems on the simple harmonic motion. So we have the two blocks, each of mass 3 kg and 6 kg. They're connected by a spring. There's a spring is there. We have a spring, and the spring constant given 32 Newton per meter and placed on a smooth horizontal surface. This surface is a smooth. The surface is smooth and spring is in its natural length. If a velocity of 6 meter per second, change this velocity. The velocity of 6 meter per second is given to 3 kg block. This one, at equals 0, is asking us to find out these things: displacement of 6 kg block, displacement of 3 kg block after some time t, the maximum potential energy, and what about how the path of the blocks with respect to center of mass. So we'll start with this one. What actually happens to the block here? Initially, what is the state of this block? This will be at rest. Spring is relaxed initially. It is natural length is drilling. We are given this block. After some time, what we see is that this block will be 6 kg block will come here, and 3 kg block will be here. Here, spring will get elongated, called kx1. And because of this spring force acting, definitely the velocity of 3 kg block will decrease slightly. So here, let it have, say, some velocity v1 dash. Now, because of this spring force acting on the block, this 6 kg block starts accelerating. So now this will acquire, say, velocity v2 dash. Then after some time, so this will have the maximum elongation, means the velocity of this block will keep on increase, velocity of this block will keep on decrease. At one instant, both will have common velocity. Both will be moving with a common velocity. And at that point, the spring will have maximum elongation. There's a one basic condition. At maximum elongation, both the blocks will have this common velocity. It's one basic idea of the spring. So spring constant K. We'll calculate this maximum elongation. How to calculate this maximum elongation? We'll apply the conservation of momentum. You see the net force acting on system plus kxm minus kxm. Net force is 0. So therefore, linear momentum will be conserved as net force on the system along x-axis 0. So momentum will be conserved. Applying conservation of linear momentum. Initially, 3 kg block was given velocity 6 meter and this is at rest. So initial momentum will be equal to 3 into 6 equal to finally 3v plus 6v. This will become 18 equal to 9v, v equal to 2 meter per second. This will be the common velocity. Then applying the conservation of mechanical energy. Conservation of mechanical energy. The initial energy of system should be equal to final mechanical energy of the system. I'll repeat once again. The initial mechanical energy of system should be equal to final mechanical energy of system. In what all form initially the energy is present? In the form of kinetic energy of block. Finally, kinetic energy of block and elastic potential energy of springs. So they should be equal to 3v0 square by 2 equal to 3v square by 2, 6v square by 2 plus k xm square by 2. This is the maximum potential energy. Potential energy is stored in the spring. You substitute all the values, we'll get this one. And this maximum elongation only will become amplitude of oscillations. So in the ground frame, after this maximum elongation, we'll get elongation. Then again, it will be compression, maximum compression. Like that, it will be a periodic. This will be a periodic. So therefore, it's going to execute SHM. About what point? About center of mass, which will accelerate. Oh, sorry, which will move with a constant velocity. About center of mass, about this center of mass, they'll be oscillating. So what's the state of this 6 kg block? They will be first natural length, elongation, maximum elongation, then elongation, next compression, maximum compression. Like this, the process will continue. And about center of mass, which is moving with a constant velocity, they'll be executing SHM. So we got the amplitude. So what is the amplitude? Amplitude will be equal to the maximum elongation or compression of the spring. I'll write it clearly. Elongation is equal to maximum elongation or compression of spring. Okay, we got this option. Maximum potential is stored in the spring. What about the time period of oscillation? The time period of oscillation, we can use the reduced mass concept. Let me will take help of the reduced mass concept. Using reduced mass concept, 1 by 6 plus 1 by 3. I think according to reduced mass concept, the effective mass of the system in such an oscillating body, oscillating system should be equal to 1 by mu equal to 1 by 6 plus 1 by 3. So this should be equal to mu should be equal to 6 into 3 by 6 plus 3, which is equal to 18 by 9, which is 2 kg. Then omega is given by formula root of k by mu. So what is the spring constant? Spring constant is 32 Newton per meter. Write down value. So 32 by 2. Reduced mass. Reduced mass is how much mu, which is equal to root 16, which is equal to 4 radians per second. What is omega? Omega is angular frequency. Angular frequency of oscillations. Okay, all kids, please like and subscribe, comment and share. Please share our channel to almost all your friends whom you know. Thank you for great support. Okay, we got the angular frequency. We have calculated the amplitude. So therefore, the particle are going to execute SHM. So what is the equation for SHM will be? Amplitude will be how much? If you calculate amplitude, will become 0.5 meter, and you try to work out this xm value. This will be how much? 0.5 meter. And omega value, it is 4. Okay, now. So in the C frame, we'll analyze the problem. In the center of mass frame, how the blocks will be moving. In the center of mass frame, we'll calculate first the C frame, how the blocks will be moving. Velocity of center of mass. Already we have calculated. I think. Let me calculate the velocity of center of mass. Velocity of center of mass should be equal to 3 into V naught, 6 into 0 by 3 plus 6. So this will be 3 into 6 by 9. 2 meter per second. What is this? Velocity of problem, little bit lengthy, but very important. Then we'll calculate velocity of blocks with respect to center of mass. Let me call this as block 1. Let me call this as block 2. Okay, fine. We'll give name. We'll calculate velocity of block 1 with respect to center of mass. V1 minus Vc. V1 is how much? 6 minus 2. 4 high cap. Or I'll use vectors. It'll be easy for you. 6 high cap. 4 high cap. Then velocity of second block. V2 bar minus V2 bar. 0 minus. This will be 2 I cap. Will be minus of 2 I cap meter per second. In the C frame, how the blocks will be moving? The blocks will be moving opposite to each other. Three kg, 6 kg. Here it will be moving with 4 meter per second. This will be moving with 2 meter per second. With respect to what? With respect to center of mass. Center of mass I'll show by some star mark. Then they will come to rest simultaneously. They'll come to instantaneous rest. Again, they'll come back to the same position. Again, they'll come back to the same position, but with velocity directed towards each other. So this will be mean. This will be extreme. Again, this will be mean position. So in fact, the blocks will be executing SHM above the, with respect to center of mass, they'll be executing SHM. So there's one basic idea will occur. So how this, with respect to center of mass, how this block, the 3 kg block will be moving away, then coming like this. 6 kg block will be moving away and returning back. Like this, they'll be continuously executing SHM with respect to each other, with respect to center of mass. So with respect to center of mass, so the block 3 kg will move away, then again come back. With respect to center of mass, this 6 kg block will be moving away and again will come back to initial position. So this will be some sort of mean position. So they'll be executing SHM periodically and at one instant they'll come to rest. This will be instantaneous rest. They'll come periodically again. So this is the basic one condition that occurs in the this given situation. Okay, now after this is asking about the displacement. What is the velocity after some time? After some time is asking us to get, if you see this particular thing is asking the displacement of 6 kg block, displacement of 3 kg block after some time t. How do we can tell all these things? So now we got the velocity of center of mass, 2 meter per second. After some time, how the position of them is what we have to check it. In the ground frame, again, we have to do. We have to work out again in the ground frame. Problem, it's a bit lengthier, I'll agree. This is a 6 kg block. Initially, no elongation, and it was given 6 meter per second. After some time, we see 6 kg block will be here, and 3 kg block will be here naturally. So this, and what is the state of center of mass? Initially, there is no elongation. So initially, spring is relaxed, and this is t equal to 0. This is after some time t. So velocity, center of mass was earlier here, was having velocity vc. Now The center of mass will be here. You can see the even center of mass is also will undergo displacement. Will not be at rest, will be having displacement. So can we calculate the displacement of center of mass? Yes, x is equal to bc into t. What is the velocity of center of mass? 2 meter per second. Okay, then, so this was 1, this will take 2 as usual. Then I'll use formula x1c. Displacement of block 1 with respect to center of mass is equal to displacement of block 1 with respect to ground minus displacement of center of mass. Okay, I agree this. Then with respect to center of mass, how much it will move? I think I need this data to displacement of block with respect to time t is asking it. Instant of time t is being asked. Now, with respect to center of mass, they'll be executing SHM. What is the amplitude? The amplitude of the oscillation, the amplitude of oscillation will be how much? X is equal to, already we have discussed this one, x equal to 2 sine omega t or a sine omega t. Amplitude is how much? 2. Omega value is 4. Already I discussed above. Scroll up and check it. This is the displacement of the block with respect to center of mass. Okay, fine. Now we'll take help of the same idea here. Now this should be with respect to center of mass. How the 3 kg block initially will move towards right. So this will be 2 sine 40. Displacement of the block with respect to ground, we don't know. Displacement of center of mass will be 2t. So this should become x1 is equal to, all are towards right. Two t plus 2t plus 2 sine 40. So this should be the in time t, the block will move this much of distance. Okay, the amplitude it is 0.5 meter, the maximum, and I'll change it. So sine of 40. Okay, now we'll write down the equation. So this will be 0.5. So therefore, this will be the position of the block 1. Similarly for the block 2, x2c equal to x2 minus xc. This will be towards left, minus 0.5 sine of 40 x2 minus 2t. So therefore, the displacement of block 2 will be 2t minus 0. Sine of 40. In what action the block will be moving towards right only. Like this, we'll get the displacement of block with respect to ground of block 1. Then this is block 2. So this, sir, can you show x1 and x2? They are here. And this little bit about relative velocity ideas is what you should take help of it. Okay, these are the required data. So the blocks will execute SHM. In fact, the blocks, they will with respect to center of mass, block 3 kg will move and return back. 6 kg block will move towards left, again start moving towards it. Like that, continuously it will be executing SHM, this one. And in C frame, the blocks will be moving away, comes to its interest, and again approaches. The same thing with the 6 kg block. And they will execute SHM with an amplitude 0.5 meter. That should be equal to maximum elongation of string in the ground frame. All these are basic ideas. Huh? Just very good problem, something related to SHM. Okay, kids, thank you very much for great support. Please like, comment, and share our channel. Thank you, all of you. We'll take the next problem. Hello, kids. We'll discuss the problem based on the simple harmonic motion. So the question is like this. We have the uniform equilateral frame in a vertical plane having mass 3m. So this is the frame, not a triangular plate. This itself is a frame. Mass 3m. So each side will have the mass m and length is L. Hinge at point. Okay, fine. Now, two ideal massless springs. They are connected of spring constant K1 and K2. Here, K1, K2. They are attached to the some rigid wall as shown, and they remain horizontal during the oscillations. We have to find the frequency of small vibration and the frequency of small vibration in the plane mentioned. Okay, in this particular plane, O is the center of the triangle, centroid of the triangle. We have to get the time period of oscillation of the G. G will act here in the vertical plane, vibrations in the vertical plane. Okay, then we have to get the time period of oscillations. Now, what is the one basic assumption? The springs will remain horizontal during the oscillation. The springs will not get tilted during oscillations because the small vibrations will assume the springs will remain horizontal. This is one basic consideration what we do in all our SHM with the spring block system or spring plate, spring rod. Requesting students to please like, comment, share our channel. Thank you for great support. Okay, now we'll start this one. So where the center of mass, first we'll try to get some data. This is the, say this is H1, H2, this total height, let it be H. So from the basics of the triangle, H2 plus H1 equal to H, and H2 by H1 equal to 2:1. This ratio by this ratio should be equal to 2:1. And from this is the (60°). So sine 60°. Here this one. Sine 60° should be equal to opposite by hypotenuse. So from this sine 60° should be equal to H by L, where H equal to L root 3 by 2. Okay, well, we need H2 and H1. Very specifically, I need H2. So I'll substitute the value here. H1 equal to H2 by 2. So H2 H2, H1 is H2 by 2 equal to H. So this will be 3H2 by 2 equal to L root 3 by 2. So H2 equal to L by root 3. So to this particular point, the weight mg will act. And this is something very important. Now we got almost all the ideas. So now we'll get into the basic working. So what is this triangle? So it will be when it'll come to this position. Will come this position and the weight will act through this particular point. The spring will remain horizontal. The spring will be connected here only and will remain horizontal. Will be oscillating. I'll try to show it. Like this. It will rotate. It will be oscillating. And the springs will remain horizontal. Some rough diagram. I don't have animations. I'm just showing it. Sir, what do you mean by oscillation? It will be like this. Small oscillations. So no, this the small oscillation it will be. So these are the length we assume data, or they are gone. Now through this, the weight mg will also act. Okay, now how to calculate all these things? How to get the it's like a angular SHM. Then how to manage this condition? So I'll go for rough diagram. Earlier this is a position. Then now you can see this. Earlier this was the initial position of the triangular plate. Fine. Now after giving small angular tilt, this will be the new position of the triangular plate. Able to analyze, no? So this is the basic thinking of this particular problem. This will be your new position. Now, what about this spring? This spring is elongated. Okay, fine. This spring will be compressed. But how much of distance it is compressed? So earlier, this was the vertical line. And there's a point through which the weight mg will act. This is theta. There's one reference line. This is theta. Okay, this is the x1 elongation of the spring K1. What about x2? X2 will be the compression of the spring. This is H2. This is a point A. Simple ideas. Okay, there's a point C. There's a point A earlier was here. Now it will come to A dash. The new position I'm showing. This will be C dash. This earlier position C. There's a point 2. So the spring is being compressed now. So the spring force will act like this. K2, X2. This is the simplest diagram. Okay, now we'll calculate, and this length should be H. No, look at this triangle. We'll calculate all these elongations, compressions. Look at this triangle. I'm taking this length is H. This spring got elongated by x1. And what is theta? Theta is the angle through which this particular line will rotate. Because as the triangle swings, how much this side will rotate, how much this side will rotate, how much this height will rotate. Same thing, this length also will rotate. This reference line. So based on that, sine theta equal to x1 by h, or x1 equal to h sine theta. This is the one thing. Then what is h equal to? H equal to L root 3 by 2. Already we have this one. I'll substitute this. X1 equal to L root 3 by 2 sine theta. Then sine theta equal to x2 by h2. x2 equal to h2 sine theta. What is h2 value? Here. L by root 3 sine theta. I think, okay, now we'll get into the problem solving. The net torque about point A. The net torque about point A will calculate. The net torque about point A will be torque due to weight mg into x2 clockwise. Here. About point A, the weight mg will act and it will set up a torque. So mg into x2, this will be clockwise. Okay, the torque due to weight about point A, we are applying the torque. Torque due to weight will be mg into this particular distance and it will be clockwise. Then torque due to this particular spring force. Second spring, K2, torque due to K2 will be, spring K2 will be, spring force will act like this, K2 x2. What is the perpendicular distance? Perpendicular distance will be, this will be the perpendicular distance, h2 cos theta. Now once again, this will be the spring force, K2 x2. This is a force. This will be the perpendicular distance. So your torque due to spring force will be clockwise about it. And it will come like this. K2 x2 into h2 cos theta. This will be clockwise. Torque due to spring force K1 x1. So how do this spring force? This elongated this spring force should act in this direction. This particular spring force, how do it act? Will act in this direction. So it will set up a torque. So what is this distance will be? This will become h, no? Total about point T. Now the torque due to the second spring force or the first spring K1 also will be clockwise. Will be like this. This is the perpendicular distance and this is the spring force K1 x1. So therefore this will be K1 x1. So this should be equal to K1 x1 into h clockwise. Substitute all and then everything should be equal to IA alpha. Why negative sign? This negative sign is like the angular displacement was given anti-clockwise, torque will act clockwise. So this should be mg x2 value L by root 3 sine theta plus K2 x2 will be L by root 3 sine theta h2 equal to L by root 3 cos theta K1 L root 3 by 2 sine theta and this is h. So therefore now sine theta very small will become theta, cos theta will be 1. So moment of inertia will calculate. Moment of inertia will be ml square by 3 ml square by 3 m L square by 2L plus m h square. Even moment of inertia calculation also you have to be careful. Moment of inertia of this rod Moment of inertia of this rod. Moment of inertia of this rod will be ml square by 3. About this end, passing through this end perpendicular. Moment of inertia of this rod will be ml square by 3. Moment of inertia of this rod BC about A will be ml square by 12 about this axis passing through the midpoint and perpendicular to plane ml square by 12 plus perpendicular distance mh square. Okay, fine. Now we'll get the moment of inertia of the next step will be, we'll write the further equation. This should be equal to alpha. Simplifying all, mgl root 3 theta k2 l square by 3 theta k1 h is equal to again l root 3 by 2. This h also I write it l root 3 by 2. So k1 3 k1 l square by 4 and this will be theta. Solving all this, simplifying, we'll get equation for SHM. We can simplify this. So the final equation for time period will be the frequency of oscillation will be 1 by 2 pi 2 by 3 3 k1 by 4m plus k2 by 3m plus root 3 g by l. This will be your final answer. We have to simplify all this. We'll get alpha. Then again, what we should do, equate this condition. Let alpha equal to minus omega square theta. We'll get omega and omega equal to 2 pi f. Solving, we'll get this should be our answer. Okay, so now look at the conditions, the ideas involved. This diagram is very important. A student must have the ability to analyze this diagram. So when it is given small angular displacement, the triangle get tilted, will take this position. Okay, this will be H2, this will make an angle theta. Then even the vertical side. This reference line also, we are just assuming for our convenience. So this particular B will have small linear horizontal displacement. The point O will have small linear displacement. So therefore, the spring will have compressed. So the springs will remain horizontal during oscillation. This is one very important idea. The springs remain horizontal during oscillations. Because as it is very small, no? Okay, fine. Okay, thanks, kid. Please do subscribe, share, comment on our channel. Thanks for great support. I will take the next problem. Hello, kids. We are going to discuss the problem based on the simple harmonic motion. So here the figure shows an oscillatory system, a compound pendulum with an elastic string. We have elastic string. So this is an elastic string or rubber cord. This particular thing, elastic string or rubber cord. The system oscillates in vertical plane here G will be acting. The rubber cord is in natural length when the rod is vertical. Okay, this is no elongation or compression. No. Find the time period of oscillations. So where he has given KL equal to mg, G equal to pi square, length where L is equal to 6 meter. Okay, we have to calculate the time period of oscillation. So what is the basic idea? Now when the rod is in slightly tilted, this particular elastic cord will behave like a spring. I given small angular displacement. The weight mg will act through here. Mg will act, and let x be the displacement of this. Let L is the length. L by 2, L by 2. L is the length of the rod. The spring force here will act in this direction. And what about spring force? The rubber cord only is an elastic, so we can treat like a spring. The spring force will act here. Then it will oscillate. So definitely the rod here will release it. It will set up a torque, will oscillate. Then after, when it comes to mean position, this will be the mean position. The rod will have maximum angular speed, and this particular elastic cord will be unstretched. No elongation or no compression. Will be relaxed. Very next moment, this will be there. So then this will become loose. This was a taut. This was relaxed. This is a basic idea of this one. And then now the torque will be only due to the weight. So here in the second diagram, this is a relaxed. So what I do is like I will slightly this is a rod. So it will rotate like this, will be oscillating. Okay, fine. The point of suspension will be there only. The rod will be oscillating. Then when it is in this position, the spring will be loose. The overall, the spring will be loose. When the rod moves towards right, this free end, this particular end which is connected, it will move towards right. The cord will get elongated, will behave like a spring. Then spring force will act. Then again it will return back. When the rod starts moving towards left, the spring, the cord elastic string will become looser. No spring force. Then what all the torque will be, restoring torque will be only due to weight. Here now when this rod is tilting, when it is oscillating from mean to right extreme position, the torque will be due to the weight as well as spring force. So therefore the time period of oscillation will be different. So we'll make a systematic idea like this. This will be 1, 1, 2. From 1 to 2, 1 to 2, 2 to 1. The time period depends upon based on this restoring torque. Time period of oscillation from 1 to 3 and 3 to 1 depends only on the restoring torque due to weight mg. So we'll write down the equation. What is sine theta? Sine theta is equal to x by L. X equal to L sine theta. Write down the torque equation. Torque about 0.2. Net torque about 0.2 should be equal to mg L by 2 sine theta. Here. About 0.2. Torque due to weight. Mg will act here. This is the perpendicular distance. Mg will act like this, and this is the perpendicular distance. So altogether, this is R bar, this is F bar. R cross F will be clockwise. So therefore, the perpendicular distance will be R bar into F. And what is this length should be equal to L by 2 sine theta. And how do this torque will be? This torque will be clockwise. Torque due to spring force, Kx into, this is the Kx. This is the perpendicular distance. What is the perpendicular distance? Equal to L. Also L cos theta. So the perpendicular distance here will be L cos theta. This should be equal to ml square by 3 into alpha. mgl by 2 sine theta clockwise. What is x equal to? X equal to L sine theta. Substitute that here. L sine theta, L cos theta. Now what will the torque due to this spring force or the elastic force set up in the rubber cord? It will also be clockwise only. Okay, fine. Now ml square by 3 alpha equal to mg L by 2. Theta very small, sine theta will become theta. Then k L square theta. For small angles, sine theta will be theta. Cos theta will be 1. Requesting students to please like, comment, and share on our channel. Thanks for great support. Okay, kids. Now we'll continue with the problem. Now this will be KL square theta. So we'll solve for alpha. Now what all the time period we are calculating only for this part from 1 to 2 and 2 to 1. Here, our problem is not yet over. So therefore this will become now alpha is equal to one more step. I think alpha will, I'll simplify for alpha. Alpha equal to G 3G by 2L theta plus K 3K by M. L square will get cancelled. 3K by M. This will be theta. So this alpha equal to minus R. Omega square theta. What is this omega? This omega is only for time taken to move from 1 to 2. We'll calculate first time period. Omega equal to 3G by 2L plus 3K by M. This omega will give one specific name, 1 to 2. Okay, the time period will calculate. Time taken will be 2 pi by omega. Now time taken to move from 1 to 2 equal to 2 to 1. And this should be called how much? T by 4. This data you keep it. Now come for, we'll calculate the, in this diagram, we'll calculate the torque. The overall the torque should be, the torque will be only due to, what all torque will be there only due to this particular force mg. So here will be the force mg will act. This R bar R cross mg will be anti-clockwise. The angle phi given was the phi given was clockwise. So therefore, the perpendicular distance will be R perpendicular into mg. What is R perpendicular? R perpendicular should be equal to, this is L by 2. So mg into torque about 0.2. The same thing for this part of the rod, for this one, should be equal to mg into L by 2 sine phi. This should be equal to minus I naught alpha. Why negative sign? Because torque due to weight mg will be anti-clockwise and the angular displacement was clockwise. Therefore, this negative sign. Equal to mg L by 2. For small angular displacement, this will be phi. Sine phi will be phi. Moment of inertia of rod ml square by 3 alpha mg L by 2 into phi. Alpha equal to 3g by 2l. So alpha equal to omega equal to, the time period will be 2 pi by 2l by 3g. Okay, sir, you are bringing two time periods. Call this is t dash. Call this as t dash. Now what we needed the total time period. No, so time taken to move from 1 to 3, 3 to 1 equal to t dash by 4. So we'll add up the total time. So what is the total time? The total time should be equal to t naught, I'll write it. This should be equal to 2 times of t12 plus 2 times of t13, 2 times of t12, t by 4, 2 times of t dash by 4, t by 2 plus t dash by 2. So these two values is what we should add up. Problem, let's be talking some calculations involved. The string will become loose. When it is loose, when the string becomes loose, there won't be restoring torque by the, when the string becomes loose, no, there won't be any spring force or the elastic force will act by the rubber cord. Only when it's stretched, there'll be elastic forces. When it is loose, there won't be elastic forces. Then the restoring torque will be only due to weight. I think that's one basic idea. Half of the time period, will be due to the torque due to weight of the rod and elastic force in the elastic cord. Half of the time period will be only due to restoring torque due to the weight. Therefore, the time periods will be different. This to why two time periods means first you should have the basic idea of the diagram. Then this mathematics, okay, fine, you'll understand. This will be total time period. Now substitute this and work out. So it will be the, after this, the calculation will be pi under root of 3g12 3k by m plus this will be pi under root of so like this solving will get the time period. substitute the values given there. Okay, please, kids, do please like, comment, and share our channel. Okay, thanks for great support. Next class, I'll upload better problems on some other topic. Till then, okay, bye. Take care, all of you. Yeah, thank you everyone. Thanks for watching.